write this down. dA plus dB. But you see, we have a rule that we use in vectors. These two letters must be the same in order for the vectors to be able to add to each other. Right? That's one thing we established in the previous videos. And the fact that this is dA, and we really want to get it starting at A, but we can appreciate what we have done over here is that we can now take the change in sign of the vectors that move from D to A to get the vector from A to D. All right? So D to A is simply going to be minus, let's see, minus D to A. So if we want, because we want to get A to D, if we minus the vector for D to A, then we are going to get the vector for A to D. Don't be confused the way how I wrote it, okay? This is a false statement. This is just what I was given, and I'm showing you that basically if we want to add these two vectors to get back AB, then we have to make sure that this vector gives us what we really want, which is starting at A. All right, so this is a wrong statement, and we put it like that. Okay? So this is really what we're going to use to end up with this. Because really, and I like to go all out, okay? Class, this is really what has to be done here. Okay? This is what we really want. AB is equal to AD plus DB. And you see what happens inside there. All right? So now it is possible. So, but we can get AD by taking the negative of DA. Let's move forward. So this is minus dA, which is A, plus dB, which is B. And we are done. Let's look here. Which one is it? Which one is it? This one? No? Okay. So answer is C. We have to make sure this sign stays with whatever the vector is. So this is okay. Good? So there we have done two questions which are in the free vector form, free vector format. And after 2 minutes, we're going to continue doing the questions on the position vectors. Welcome back, students, to our class, continuing on vectors. Now we are going to focus on some questions in relation to position vectors. Now, position vectors can be very simple for you to solve, but if you don't have a good understanding of the foundation in position vectors, then you're going to get some problems. All right? And remember, the main difference for position vectors as compared to the free has B in it. So let's just write this down. dA plus dB. But you see, we have a rule that we use in vectors. These two letters must be the same in order for the vectors to be able to add to each other. Right? That's one thing we established in the previous videos. And the fact that this is dA, and we really want to get it starting at A, but we can appreciate what we have done over here is that we can now take the change in sign of the vectors that move from D to A to get the vector from A to D. All right? So D to A is simply going to be minus, let's see, minus D to A. So if we want, because we want to get A to D, if we minus the vector for D to A, then we are going to get the vector for A to D. Don't be confused the way how I wrote it, okay? This is a false statement. This is just what I was given, and I'm showing you that basically if we want to add these two vectors to get back AB, then we have to make sure that this vector gives us what we really want, which is starting at A. All right, so this is a wrong statement, and we put it like that. Okay? So this is really what we want to take half of. tell us? Well, we could say 6, 4 is equal to half of 12, 8. Because you're in Form 5, you know your numbers. If you take half of 12, you get 6. If you take half of 8, you get 4. So this would be what makes the equation balance on both sides. So we know for sure that PQ is going to be 12, 8. So 12, 8 is our answer. Another way someone could have done this is by first rearranging the ratio that you are given, the relationship that you are given in the original question. So AB, half, PQ. And that's what we really did to solve it. Now if you take half over as a multiplier, it comes over and it does what? Divide. Because we want to get PQ to be by itself. Alright? Making PQ the subject of the equation. So we are connecting different understandings here. So if we bring half over, because it is multiplying by PQ, half comes over and it divides. Alright? If we are dividing by a fraction, we change the division sign to multiplication and we flip the fraction. So this 2 will come over and be a multiplier. You can even look at it like if you were to use this idea. Sometimes you can use that when you're multiplying. Okay? So if I'm transposing, when this half comes over, the 2 comes over, it multiplies. Because over on this side, it is dividing. So this would be simply given as 2a. And we have to learn to manipulate these kinds of relationships, these kind of ratios to help us solve questions easier. Because if we did this, had we done this, then you would have seen straight away that if you take this and carry over 2AB, twice of AB is equal to PQ. So you take twice of this and you get 12, 8. Very, very nice tools that you can use and make your question easier for you to solve. Okay, so we have solved this one and we got the answer to be 12, 8. Let us look at numbers 4. So I'll give you 1 minute to try that solution. See if you can come up with an answer. I will just talk in the background so you get some motivation and you get some memory of what you need to do. Always remember, class, when you are doing when you are solving your multiple choice question, read. You must read the question carefully. Okay? Reading is very important to pass maths. Never mind you don't have to be an excellent English person, but what we are saying is you must have some understanding of what the words in the question, what meaning is behind, what meaning goes with the words that are used in the questions. Alright? Now if you look at this, because the time is up, so we need to do the solution now. Oh, you still have time. I'm sorry. I'm working a bit too fast. All right, point taken. Now, let's continue. So we have to remember here, position vector means it starts from the origin 0, 0. Okay, it has to start from the origin 0, 0. And in our previous video, we also said that when you are adding or subtracting two vectors that are in the free vector format, the process is not the same as if you were to add two vectors that are in a position vector format. And we identify why that is so, because for position vectors, the origin is 0, 0. So you are not going to have a direct link moving from, let's say, one vector P to another vector Q. Because we usually come back down to the 0, 0 point and then go up to the other vector. All right? Now, so your time is up, so let us go to the solution and we will look at different ways of reasoning this solution as well. Okay, so given that OP is equal to 4, 3 and PQ is equal to 1 minus 1, where O is the origin, all right, the position vector of Q is And remember, class, this is important. The position vector, let's underline that. The position vector of Q. The position vector of Q starts from O, ends at Q. So this is what we want to find. We want to find what is OQ. All right? So we want to find what is OQ. So OQ, and we can use the arithmetic method. So OQ is equal to, we have to start at O, remember? So we have to start at O. We have two vectors given here. OQ is equal to OP plus PQ. Now this one is nicely laid out for us. Okay? These we can add easily like that because remember this is not a position vector. Alright? This is from P to Q. Okay. Now, let's walk it and see what happens. So OP is 4, 3 plus PQ, which is 1 minus 1. Okay, components add with components that are like. So this one's fairly easy. 4 plus 1 gives me 5. 3 plus minus 1 gives me 2. So I trust that you got that answer. Now somebody might have asked, what is another way you could have done this? What is another way you could have done this particular solution? So I'll wait for you to give me your suggestions. What are your suggestions? Somebody is talking, yes? Let's try. Someone said, let's try the graph and see what happens. Let's try the graph and see if we can, guide ourselves to the solution. So let's assume this is our graph. This is our origin, 0, 0. We have these numbers, 1, 2, 3, 4, 5, 6. Positive, 1, 2, 3, 4. And I can't do this because this is a sketch. This is not really me putting it exactly on the graph, but I'm just going to guide myself, okay? And we don't need to be too bothered, but just to get an idea of what we are doing. So here, they give us these two vectors, OP. So OP is the vector which goes 4 across and 3 up. So OP is 4 across and 3 up. Let's see. 1, 2, 3, 4. 1, 2, 3. So let's assume our vector P is there. If we were to draw this. So this is our vector OP. Don't forget the arrow. And then they're telling us that we're going to continue from P and move to Q. So the movement, remember the vector is a movement, okay? So the vector that moves me from P to Q would be 1 across and 1 down. So we move from P, 1 across to the right and 1 down. Let's see what happens. So from here, remember we are here at 4, okay? Don't forget we are at 4 here. So we move 1 across, which means we'll be now aligned with 5. And then we move 1 down. Remember we were at 3 here. So if we move 1 down from 3, we'll end up at 2. So we're going to end up here at this part to give us the vector for PQ. Okay, let's put our arrows. So the vector, the position vector for OQ would be starting from O and ending at Q. And we can appreciate it will give us 1, 2, 3, 4, 5 across, 1, 2 up. So we end up with the same 5, 2 for the vector O to Q. Okay? So now we are going to continue with some questions, but this time, when we return after 1 minute, I'm going to set them for you to do as homework exercise. Don't forget, to be excellent, you need to practice. And when you practice, you become very good at what you want to do. So for vectors, I'm going to set 2 questions for you to do for your homework.